of DC motor and AC motor.
This call is now being recorded.
So the same I have discussed here also. So how I'm going to select a motor? The first one, see why I'm selecting a motor? Because a drive, if I'm saying a drive is nothing but a motor plus solid state drive. Already said, any system which is employed for the motion control, it is called drive. So for the motion control, I have go with the drive motor only. So the selection of motors play a vital role in the drive. Yes. So what will happen? These are the motors the available. Apart from that, I can choose the some special electrical motors. It is I will say after the DC compound motor. In some cases, they have set the stepper motor and then VLDC motor and then PMSM motor. Before that, you should know why I'm going to the topic. So the electrical drive is consist of electric motor associated with the control of. So what will happen? In order to control the drive, I have to move with the motor only. If I'm controlling motor, what will happen? It is followed by the load. So I can easily control the load with the help of my motor. Again, I can control the motor with the help of the power modulator followed by the control unit. So this is what I thought in the block diagram of electrical drive. So it is a closed setup. So everything is depends upon the other parameter. So the load is depends upon the motor is depends upon the power modulator, and the power modulator is followed by the control unit and sensing unit. So this is the whole setup, the whole block diagram of drives. So particularly I'm talking about the motor side. First one, AC motor and then DC motor. AC motor, I would say if my supply is AC, I used to say is a AC motor. The AC motor is further classified into induction motor and synchronous motor. The AC commutator motor, I will say again. First one, induction motor. Induction motor is nothing but, already said, the domestic application, we are using the induction motor only. The induction motor is nothing but the asynchronous motor. Asynchronous motor means the motor will run at below 1500 rpm or below synchronous speed. It's called asynchronous motor, which means my induction motors will run below 1500 rpm. Please note it down. Please note it down, all of you. So, induction motor below 1500 rpm or below synchronous speed. In synchronous speed is nothing but 1500 rpm.
Ma'am, once again repeat, ma'am.
Okay. The AC motor is the types of AC motors come under a induction motor and synchronous motor. Induction motor is nothing but is the asynchronous motor. Asynchronous means this type of motor will run at below synchronous speed. Synchronous speed is nothing but 1500 rpm. And I used to say is that N is equal to 120 F/P. This formula have set in the basic class, in the first class of electrical drive.
Ma'am, voice is too low, ma'am.
Once again. Yes. So induction motor is run at below 1500 rpm. So the another name of induction motor is asynchronous motor, which means it never runs at a synchronous speed. It always runs below synchronous speed. So synchronous speed is nothing but Ns is equal to 120 F/P. Already said. In my another name, Vidalakshmi R, they have written the formula NS is equal to 120 F by P is nothing but 1500 RPM is nothing but the synchronous speed. I can derive the speed with respective of this formula. This is the formula to find out the synchronous speed. Ns is equal to 120 F by P. Ns is nothing but synchronous speed. F is nothing but frequency, and P is nothing but number of poles. I'm repeating once again. Ns is equal to synchronous speed.
மேம்
Yes, sir.
விஜய் மேம்
Yes, sir.
இது கரெக்டாக தெரியல மேம் கிளாரிட்டியா.
Okay, sir. Now is it okay?
வித்யா
Yes,
மேம்
sir.
கிளாரிட்டியா கேட்க மேம் கிளாரிட்டியா இதாகல மேம் ப்ரொஜெக்ட் ஆகல.
Okay, sir. Now is it okay, sir?
இல்ல மேம் அது அந்த மூவ்மெண்ட்ஸ் இருக்கிறதுனால அது தெரிய மாட்டேங்குது மேம்.
Okay, sir. Please note it down. I will say. So Ns is nothing but synchronous speed. F is equal to frequency and P is equal to number of poles. So based on this, I can find out the synchronous speed of my induction motor as well as my synchronous motor. Again, the synchronous motor is further classified into squirrel cage induction motor and then slip ring induction motor. In my another name, Vidya R, there I have shown the PPT. There, the types of induction motors is there. Please note it down. The induction motor is further classified into squirrel cage induction motor and slip ring induction motor. I will go with induction motor, after that followed by synchronous motor. First, I will complete the induction motor and then I will move with the next one, synchronous motor. So, a squirrel cage induction motor is least expensive of all motors. Compared of motors, I can refer a squirrel cage induction motor as least expensive. So, least cost compared to all type of motor. Please note it down. Please note the hints. For example, squirrel cage induction motor, you should write the least expensive. That's enough. And then it is robust in construction and then maintenance free. So compared to all the other types of motor, I may use the squirrel cage induction motor because of the least expensive and then robust in construction and then maintenance free. So, and then this type of motor I can directly switch to the supply. And then the variation of speed from no load to full load is very small. I'm repeating once again. This type of motor, the squirrel cage induction motors can be directly switched on to the supply, and then variation in speed from no load to full load is small. Normally, we cannot directly use the supply to motor. We have to connect the starter. But squirrel cage induction motor, in some cases for low power application and then low speed application, I can directly connected to the supply. There I have uses the online starting, which means you can directly start the induction motor. The main drawback of this motor is it is low starting torque, which means if my machine is low starting torque, it will be run at a low speed. It cannot use for the high power and high speed application. So the main drawback of the squirrel cage induction motor is low starting torque. Low starting torque means it will be run at a less speed only. We cannot use this type of motor for high speed application. And then it's a poor power factor. Poor power factor, already said, power factor is nothing but the angle between a voltage and current. So normally we prefer the unity power factor. If it is poor power factor means my efficiency will be very less. If my efficiency is less means we cannot prefer the less efficiency motor. In all the time we need a efficiency is high. Efficiency nothing but output by output. So if motor is poor power factor, it will be affect on my efficiency. So it's another drawback of this squirrel cage induction motor. And then the next one, limited frequency of starting. We can use for the limited period only. And then if I'm starting without starter, it may affect the supply voltage. I'm repeating once again. If I am starting a motor without starter, it may affect the supply voltage. So what will happen? The capacity of the supply system is very large. So this is the drawback of the squirrel cage induction motor. So where I'm going to, therefore, the widely it can be used for the less speed application. We can use in the squirrel cage induction motor in to drive the fans, pumps, conveyors, and lathes. I'm repeating once again. It can be used in to drive the fans, pumps, conveyors, lathes. Listen once again. A selection of electrical motor. In that, I have said talking about the AC motor. The AC motor is classified into induction and synchronous motor. Induction motor is a synchronous motor, which means it will be done at a below synchronous speed. Synchronous is nothing but Ns is equal to 120 F by P. So normally we used to say synchronous speed is 1500 RPM. So it will be never runs at a synchronous speed. It will be run below synchronous speed about 1490 or 1480 or 1400 RPM. So the induction motor is further classified into squirrel cage induction motor and slip ring induction motor. Here I have talked about the squirrel cage induction motor, where I have chosen the squirrel cage induction motor. So from my point of view, the squirrel cage induction motor we can use for application because it is a low starting torque. Low starting torque means it can be used for the speed will be very less compared to other type of motor. If it is high starting torque, it can be done at a high speed. Okay. So and then what the advantage of induction motor means it is the least expensive and then robust in construction and then maintenance free. And then we can directly switch on to the supply and then variation of speed from no load to full load is small. So these are the advantage why I am moving to the squirrel cage induction motor. And then have said the drawbacks. I'm repeating once again. The drawbacks of the squirrel cage induction motor is low starting torque and then poor power factor and then limited frequency of starting. I already said poor power factor means we have moved with the unity power factor. Unity power factor means my efficiency will be good. If it is poor power factor, my efficiency will be affected. So what will happen? My output will be very less. The efficiency is less means we won't go with the type of motor. So probably we have used this type of motor for low power application or low speed application. Where I'm using this type of motor means to drive the fans and pumps and conveyors and lathes. Already said AC induction motor. We have talked about the fan example. There we use the squirrel cage induction motor only. And then if you have any doubt in squirrel cage induction motor, if you have, tell me, and then I have moved with the slip ring induction motor. Okay. No. The next one is slip ring induction motor. Compared to squirrel cage induction motor, slip ring induction motor is expensive, but compared to squirrel cage, it has an advantage because here the slip ring induction motor is high starting torque with low starting current. So obviously, if it is high starting torque means the slip ring induction motor I can run for the high speed application. Yes. And then here the rotor losses are mainly in external leg resistance. In slip ring induction, the additional resistance with the help of the rotor. I'm repeating once again. If we want, in order to reduce my starting current, why I'm going to reduce my starting current means if I'm starting a machine, any motor, what will happen? The starting current will be very high. So if my starting current is high means my machine will run at a dangerously high speed, or it may be it will be changing variably. So in order to avoid that, I have go with the starter. The starter is nothing but why starter main function is, and it will helpful to reduce the starting current. I'm repeating once again. See why I'm going with the starter means without starter, if I am starting any machine, the starting current will be very high. If my starting current is high means the machine will run at a dangerously high speed. So in order to avoid that, I'm using a starter. Yes. Any doubt? Have I noted the function of starter? Why it is used for to start the motor and all? Have you all noted down?
Once more, ma'am.
So I'm repeating once again. We can start the motor without starter. But if I'm starting a machine without starter means what will happen? The machine has some high starting current. So what will happen? If the machine is high starting current, the speed will be dangerously high. So நமக்கு என்ன அர்த்தம் அப்படின்னா எடுத்தோடனே எனக்கு மெஷின் ஆன் பண்ண உடனே என்னோட மெஷின் ஸ்பீட் வந்து ஹையா இருந்துச்சுன்னா we cannot be managed. Yes, if I switch on the fan, what will happen? It will be slowly pick up the speed. Yes or no? Yes.
Yes, ma'am.
If I didn't start with the starter, what will happen? The fan will be dangerously high speed. What will happen? It will be affect the whole drive system. In order to avoid that, I'm using a starter here. So starter is nothing but it is made up of the resistance only. I will teach about what is starter and all in the module 3. Before that, you should know the function of starter. Why I'm using a starter to start the motor? In order to limit the starting current and the starting torque also. Because torque is directly proportional to current and to flux. So if my starting current is very high, my starting torque also very high. So what will happen? My machine while starting will be run at a dangerously high speed. In order to avoid these functions, I have moved with the starter. Yes. Any doubt? Have you all got my point? What I'm saying?
Yes, ma'am.
Yes. Must say yes or no?
Yes, ma'am.
Okay. So that's why I have using starter for starting any type of motor. So the next one, I have talked about the slip ring induction motor. The slip ring induction motor is expensive than the squirrel cage induction motor, but it has an advantage of higher starting torque and then low starting current. So there I have got low starting current. I have said why, and then why I'm moving with the starter and all. So, and the next one, in order to, in some cases, in squirrel cage induction motor, in order to reduce the starting current, I can add the number of resistance with respect to my rotor side. I already said the main part of the AC motor is stator and rotor. In rotor, I can add the number of resistance in order to reduce my starting current. In some cases, we can in all the cases in stator. Before that, you should know the starter concept. The start is nothing but, already said, in order to limit the starting current, I have connected the with respect to motor. So, in the main function of starter to limit the starting current. So, what is there in the starter means it is all made up of the resistance only. There, I have connected the more number of resistance. So, if I am connected resistance with respect to my armature, what will happen? V is equal to IR. So, I is nothing but V by R. If continuously I am increasing my resistance means what will happen? My current will be reducing because my resistance is inversely proportional to current. So that's why I have added, in order to limit the starting current, I have added the starting resistance. So the starter is nothing but it is the made up of the resistance only. So all the resistance I have to add with the center part of the motor. In case it is a AC motor, I am going to add the resistance into the rotor. If it is DC motor, I have added the resistance to the armature. So this is what that said in the point. So the rotor losses are mainly in the external resistance because in all the cases we cannot directly add to the rotor side. But in slip ring induction motor, you can easily add external resistance to the rotor. But in squirrel cage induction motor, we cannot change anything into the squirrel cage. But slip ring, you can easily change the number of resistances. That's why compared to squirrel cage induction motor, the slip ring induction motor, we are mostly preferred for the high speed application. Yes? Yes? Any doubt?
மேம் ஏசி மோட்டார்ல ஸ்டேட்டர் அப்படின்னா டிசி மோட்டார்ல என்னன்னு மேம் சொல்லுவோம்?
Field armature.
ஃபீல்டா மேம்?
Yes, field winding, armature winding.
ஓகே மேம்.
Yes. Any
Yes,
doubt
ma'am.
in slip ring induction motor? I'm repeating once again. So, compared to squirrel cage induction motor, slip ring induction motor is best because it is high starting torque with low starting current, and then you can easily add number of resistance with respect to rotor, and then the losses will be depends upon the external resistance only. So the losses will be less in the slip ring induction motor, and then you can easily start and stop frequently. So, but squirrel cage induction motor, it is not possible. We cannot start and stop the motor frequently, but in slip ring induction motor, it is possible. And then again, I already said it's a high starting torque, so it is used for drive the heavy loads because of the high starting torque. And then it is used in the conveyors and elevators. Is any doubt? Is it clear? Or shall I repeat once again? Is it clear or not? I'm talking with you only. Shall I repeat or shall I move to the next topic? Is my voice is audible? Somebody unmute and say. Is it clear?
Yes, ma'am. Voice is audible.
Yes, ma'am.
Okay. Have you all understood what is slip ring induction motor? Or shall I repeat once again? Mom, say yes or no. Okay, move to the next one. Once I finish the selection of electrical motor, I will recall from induction motor once again. And the next one is synchronous motor. Synchronous motor is nothing but the machine will run at the synchronous speed, which means a synchronous motor is always done at 1500 RPM. And then it is a constant speed motor. So why I'm going with this type of synchronous motor, because and then it has some drawback also. And then what are the drawback, man? It is a higher initial cost compared to squirrel cage induction motor. I'm repeating once again. Synchronous motor is nothing but it is run at the synchronous speed, which is nothing but 1500 RPM. It is a constant speed motor, and then it has some limitations and then advantages too. And then what are the drawbacks? Means it is high initial cost compared to squirrel cage induction motor. And then again, the running cost can be improved by changing or improving the power factor. If my power factor is best, the running cost will be good. So depends on the power factor, the running cost will be varying. And then again, it's a constant speed motor, so it cannot be used for the variable speed application. It is only for constant speed. Where I have used the constant speed, I can use the synchronous motor. And then another drawback of the synchronous motor is it is not self-starting. We need special arrangement to start the motor. Yes. So there, this type of synchronous motor we have used for the drive, which can apply for the constant speed. Ingala unga constant speed தேவைப்படுதோ, there you can use for the synchronous motor. Yes. Have you all noted it down? I'm repeating once again. I have took this question from the selection of electrical motor only. So there I have asked about the squirrel cage and slip ring induction motor and all. If you not attend the quiz or if you not pass the quiz, means I won't give attendance. So listen my class carefully. I will repeat once again once I finish the selection of electrical motor drive. Yes? Is it clear? Is it clear what is meant by synchronous motor and all? Is anybody there? Somebody unmute and say, is it okay? Shall I move to the DC motor? Is my voice is audible? My message in chat box also. Shall I move to the next one or shall I repeat the synchronous motor once again?
Next one, ma'am.
Next one is
Next
DC
one.
motor. So compared to AC motor, DC motor is expensive and then it requires periodic maintenance. Why it is expensive means the DC motors require commutator and brushes. The DC motors require commutator and brushes. Why? What is the function of commutator? Why I am using a DC commutator in DC motor?
Commutator used to convert the AC into DC, ma'am.
Yes. That's why. Is it correct? So without commutator, DC motors it cannot be run at a DC because normally the function of if the two interacting flux will produce AC in nature. In order to convert DC, I need commutator. So the DC motors are required commutator and brushes. So compared to AC motor, it is a bit expensive and then it requires periodic maintenance. And then if my supply is AC, in order to drive the DC motor, I need converter because I need to convert my AC into DC. Yes, I need rectifier. Yes or no?
Yes, ma'am.
I'm repeating once again. if my motor is DC motor, but my supply is normally available AC. So in order to convert my AC and DC, I need special arrangement. That means I have go with the rectifier because rectifier is converting my AC voltage into DC voltage. So the total cost of the system will be more because I have added the rectifier here. So uh, therefore the DC motors are usually only when AC motors are not suitable for to fulfill the special arrangement. அதாவது எப்பெல்லாம் எனக்கு AC will not fulfill the special in some cases AC will not used for the drive means I have moved with there is no option. I have moved with the DC drive only. There I have used the DC DC motors. In DC motors is further classified into separately excited DC motor and self-excited DC motor. In self-excited DC motor is further classified into shunt motor and series motor and compound motor. Separately excited motor means the field is excited separately. I have given the separate excitation to the field winding. Already said. Yes, the very basic class I have told about the separately excited motor and self-excited motor. In separately excited motor, I have given separate supply for field, so that is called separately excited motor. But self-excited motor, it is excited with the help of the armature. If I'm giving a supply to the load or field, it will be self-excited from the supply. So self-excited motor is further classified into DC shunt motor and then DC series motor and then compound motor. Series shunt motor is nothing but if my field winding and armature windings is connected in parallel, this is called DC shunt motor. Which one? The another name of Vidyalakshmi Art. I will draw the shunt motor and series motor diagram. Then there you can understand what is shunt and series motor. If it is not clear means once I draw and then explain what is image shunt motor and series. I think this is visible. Is it visible? No. Now is it okay? Not clear. Now is it okay?
மேம் அது அது கரெக்டா ஹோல்ட் ஆகாதனால தெளிவா பார்க்க முடியல மேம்.
சார் சொல்லுங்க சார் பாருங்க. ஓகேவான்னு பாருங்க அப்படியே.
நீங்க இந்த இருந்ததுன்னா அதுல அப்படியே ஹோல்ட் பண்ணி வச்சிருங்க மேம்.
Now is it clear, sir?
மேம் இப்ப வாய்ஸ் வரல மேம்.
Voice வரல சார்.
இல்ல வாய்ஸ் வந்தாலும் அவ்வளவு சவுண்டா இல்ல மேம். லோ இதுவா இருக்கு.
Sir. Now is it visible? Is it visible? Charles sir.
மேம் இப்போ ஓரளவுக்கு பரவாயில்ல மேம்.
Charles,
ஓகே, பழைய இதுக்கு இது பரவாயில்ல மேம்.
is my voice is audible? Yes sir.
மேம் உங்களோட அந்த வாய்ஸ்க்கான அந்த இது இல்ல மேம். ஸ்கிரீன் ஷேரிங் மட்டும்தான் இருக்கு
Sir. Yes sir.
மேம். ஓகே ஓகே. வாய்ஸ் சேனல். ஓகே மேம்.
Sir. Sir. கேக்குதாங்க சார் இப்போ? Sir. My voice is audible now? All of you? Yes. Please draw the diagram. Pin my another name. There I have draw the shunt motor and series motor. If my field and armature winding is connected in parallel, so this is called shunt motor, DC shunt motor. If my field winding and armature winding is connected in series, it is called series motor. See, draw the diagram, shunt and series motor. I think now my image will be clear, I think. Have you all drawn the diagram? Shunt motor and series motor diagram. Yes, have you all drawn? Yes. you're done, please switch. Please pin my another name. If you're done means please pin my another name there. PPT available. I will move with that. If you all done, please pin my another name. I think all have all copied. I think I'll move to my PPT. So, if my field winding and armature winding is connected in parallel, it is called DC shunt motor. And then if both winding is connected in series, it is series motor. A compound motor is further classified into long shunt, short shunt, and differential and cumulative motor. So this is not needed in the first module. I will teach detailedly in the module 2. And then compound motor series and series winding and then field winding. It is have two winding. Say later. While coming to the DC motor, so whenever my supply is AC, we need special. That means a converter is required to convert my AC into DC. The total cost of the system becomes still more. It will be high. And then whenever the AC is not suitable to fulfill the special requirements of the load, then only I can move with the DC motors. For some, in some conditions, why I'm moving to the DC motor means the fast, accurate, and continuous speed control over a wide range that I can use for the DC drive. So the DC drive I can use for the rolling mill and paper mill and then mechanical processing and then heavy articles. I can use for the DC drive. So for this type of drive, this type of application, I can use for the separately excited DC motor. I'm repeating once again. In some special requirements for the fast, accurate, and continuous speed control over a wide range that I can use for the DC drive. Particularly, I can move with a separately excited DC motor. And then in some applications for cranes and hoist and then electrical traction, I need a very high starting torque. And then for a lower torque for higher speed. In some such application, I can use for the DC series motor. Because the DC series motor is a high speed motor. So why means I will say clearly in second module. Before that, you know the basics. So shunt motor is constant speed motor. It will be run only in the constant speed, but series motor, it will run for the high speed application. So probably for hoists and cranes and electrical traction and all, we have used for the DC series motor only. See, again, I'm repeating, based on our application, we can choose the type of motor in some condition. If I need a high speed drive, so there I can choose for the AC motor, AC slip ring induction motor, or for DC motor. In further, I need a fast, accurate, and continuous speed control. There I can move with the DC motor. Instead of slip ring induction motor, I can go with the DC motors. So DC motor I can use for the fast, accurate, and then continuous speed control over a wide range. So for this application, I have moved with the DC motor. And then the next one is AC commutator motor. So the AC commutator motor, in some cases, I can use for the instead of DC motor, I can use for the AC commutator motor because the power factor and then speed can be controlled. I'm repeating once again. Normally, in AC motor, we don't have commutator. Yes or no? In some special applications, the AC commutator motor and stepper motors are come under special electrical machines. In AC motors, it hold commutator. That's why the name it as AC commutator motor. In some application, I need a better power factor and then better speed. I can move with the AC commutator motor. And then the last one, is stepper motor. Stepper motor, it's a special electrical machines. Apart from DC motor and AC motor, in some special motors is there. The special motors are AC commutator motor, stepper motor, BLDC motor, and PMSM motor. So mainly the stepper motors, why I'm saying this means we can use it for the computers. Stepper motors are used in the digital systems. The motor can convert input information into digital form to output, which is in mechanical. So many computer side and many mechanical side we can use it for the stepper motor. So this type of motors are widely used in the computer industry. So mainly it is used for the drive paper feed mechanism in line printers and printer terminal. You can see the stepper motor in printers and then floppy disk drives. There you can use it for the stepper motor. And again, it is used to perform mixing and cutting and stirring function also. So in some cases, it can use it for the cutting machine and fixing machine, stirring machine. You can use it for the stepper motor also. So normally the stepper motor are used for the digital system. All the computer industry, it is widely used because of it is convert the input information into digital format. So even though my input is whatever may be, it will convert into digital form, zeros and ones. So that's why in computer industry, the stepper motors are widely used. I think I have talked about the selection of electrical motor. I'm repeating once again. The selection of electrical motor, please note it down. If you have not noted down any important points, or if you not listen the important points, please listen once again. Please note it down. I'm repeating once again the selection of drives. So why I'm going with the selection of electrical motor means we have to every time we have to talk about the speed torque characteristics, because particularly the type of motor. So it is influenced based on the speed torque characteristics. So it's always matched with the load speed torque characteristics. So in order to find the speed torque characteristics, which speed in which speed we can choose for the motors and all, you have to move with the selection of motor. So the selection of motor is come under a DC and AC motor and some special electrical machines also. So the AC motor is classified into induction motor and synchronous motor. Induction motor is nothing but is a asynchronous motor. Asynchronous motor is nothing but it will be run at the below 1500 RPM. The 1500 RPM is synchronous speed. So the induction motor is never under synchronous speed. That's why it is called asynchronous motor. Induction motor is classified into squirrel cage induction motor and slip ring induction motor. Squirrel cage induction motor is nothing but it's a least expensive compared to all type of motor. It is least expensive and then robust in construction and maintenance free. So and then you can directly switch it on to the supply, and then variation of speed from no load to full load is very small. So that's why I have moved with the squirrel cage induction motor, but it has some drawbacks. It is low starting torque and poor power factor and limited frequency of starting. And then if I am switching on directly to the supply means the supply voltage will be affecting. So these are the drawbacks of the squirrel cage induction motor. And then this type of motor can use to drive the fans, pumps, conveyors and lathes. And then next one, slip ring induction motor. Compared to squirrel cage, it is more expensive, but it has advantage of higher starting torque with low starting torque. And then the losses mainly depends upon the external resistance. Normally, the starter, in order to start the machine, I go with the starters. Starter is nothing but in order to limit the starting current, I have added the starter. Starter is nothing but it's made up of the starting resistance, because the resistance nothing but if I'm including resistance means my current will be dropped out, because I is inversely proportional to resistance. If you are in order to limit the starting current, I have to add the additional resistance with respect to rotor as well as armature. In case it is my AC motor, I have to add the external resistance to my rotor. But in slip ring induction motor, you can add the additional resistance to the slip ring. That's why compared to squirrel cage, mostly we have used it for the slip ring induction motor. Not only you can add the extra additional resistance motor, but for the high starting torque. If my machine is high starting torque means it can be run at a high speed. So for high power application, high speed application, I have moved with the slip ring induction motor. So, and then you can easily frequently start and stop the motor. So this type of motor to drive the heavy loads requiring high starting torque. When some cases, when some drives need a high starting torque and for driving the heavy load, that I can use for the slip ring induction motor. And then already said for it can be easily start and stop. So for better application, instead of squirrel cage, all the drives you can see with the help of the slip ring induction motor, because it can easily start and stop the motor. And the next one is synchronous motor. Compared to induction motor, synchronous motor is higher initial cost, but it can be used for the constant speed. In case if my drive need a constant speed means 1500 rpm means I can move with the synchronous motor. And then another advantage of this synchronous motor is I can improve my power factor. The running cost, I already said the initial cost of the synchronous motor is high, but I can reduce the running cost by improving my power factor. So again, another drawback of the synchronous motor is it is not self-start. We need a special arrangement to start the synchronous motor. So again, what will happen if I'm adding another special arrangement means again my system will be cost wise it will be increasing. So the initial cost again it will be increasing. And again, whenever we need a constant speed, there you can use for the synchronous motor. And the next one is DC motor. Compared to AC motor, DC motor is expensive and then periodic maintenance is needed, because why it is expensive means it requires commutator and brushes. And then again, if my supply is AC, we need a converter to convert my AC into DC. Again, the total cost of the system will be increasing more. And then DC motor is only used for when AC is not not suitable to fulfill the special requirements. There I can use for the DC drives. The such special requirements are what are the special requirements means the fast accurate and then continuous speed changes are, which means continuous speed control over a wide speed range. There I can use for the DC drive instead of AC drives. So in DC drives, where I can use for means paper mills and then rolling mills and then mechanical processing and position of heavy articles. There I can use for the DC drives. And then in such applications, we can use for the separately excited motor. And then next one for cranes and hoists and then electrical traction, we need heavy starting, very heavy high starting torque is required. There I can use for the DC series motor. And then last one is AC commutator motor. AC commutator motor is nothing but the AC motor which has the commutator part. So while I need a power factor and then speed control, there I can move with the AC commutator motor. And the last one is stepper motor. Stepper motor is nothing but it is used for the digital system, because this type of motor is convert input information into digital format to the output. So that's why it is used in the computer industry, and then for driving a paper or printers and then printing on a floppy disk drives, there you can use for the stepper motor. So this is the selection of electrical motor. I am repeating once again, based on our load and then based on our requirements, we can choose the type of motor. Yes? Any doubt in it? Any doubt? Is it clear? Is it clear or not? Yes. Now somebody unmute and say, is it clear? Is it clear or not? Is my voice is audible? Do you have any doubt in selection of electrical? Do you have any doubt? Do you have any doubt in this topic? Must say yes or no. Do you have any doubt? Yes. Karan Velen. Any doubt? Must somebody unmute and say if you have any doubt, you can ask question now. Must say yes or no. Then only I can move with the next topic. Is my voice is audible now?
Yes, ma'am. Audible, ma'am.
Any doubt? Regarding selection of electrical motor, any doubt? Now, if you have any doubt, please make the question now. Is it okay? Shall I move to the next one? Must somebody unmute and say? No doubt. Shall I move to the next one? Yes. The next topic is selection of enclosure. Yes. The next one is selection of enclosure. There's nothing but the electrical motor used in the drive or enclosed with a cover to protect the from dust. என்ன அப்படின்னா மோட்டாரை ஏதாவது ஒரு கவர் பண்ணிப்பா ஒரு என்க்ளோஸ் பண்ணிப்பா மோட்டாரை ஏன் அப்படின்னா in some cases we need to prevent from human contact or dust or in some explosive atmosphere we have covered the motor with some enclosure. So why we have used for the enclosure and what are the types and then which type of enclosure we have used in the application. This is what I have going to say in the selection of enclosure. I'm repeating once again. Normally the drives are enclosed with some covers to protect from dust and then environmental aspects. So in order that we have divided into 4 types: screen protected type and trip proof and then totally enclosed type and flame proof type. In order to prevent from the environmental aspects and then the coming in contact with motor. Sometimes the rats and squirrels are went inside the motor. In order to prevent that, I have go with the selection of enclosure. So the first one is screen protected type and trip proof type. The first one is screen protected type. So this type of enclosure has large opening which is covered by wire mesh. வீட்ல பார்த்துட்டு பண்ணி வயர் மெஷ் அதாவது நீ ஸ்கிரீன் பண்ணிருப்பாங்க வீட்ல நம்ம நெட் கட்டிருப்போம் கொசலா வராம இருக்கிறதுக்கு ஸோ அந்த மாதிரி we can use for the screen protected type to cover the machine. So why means because to protect the motor from the dust and then it provides protection from coming in contact with the motor. Already said in some motors the rats and squirrels are living inside the motor. In order to avoid these problems, it is covered by the screen protected type. And then another advantage is in some cases the motor run ஆயிட்டு இருக்கும்போது கையை கீழே வச்சிருவாங்க அந்த மாதிரி டைம்ல எல்லாம் we have to enclose some type of covers. So This is the one type is screen protected type. The screen protected type is used for the wire mesh screen. So it will be more ventilation possible because it is screen type. So it can be the the ventilation is possible, and then product from the dust, and then again another advantage of the screen protected type is coming in contact with the mortar. So this is the screen protected type. The next one is drip proof type. Drip proof is nothing but if my atmosphere is damp or submerged. If some cases we can use, I'm going to submerge my mortar in river side. There I can use for the drip proof type. So the drip proof enclosure is used for the submerged mortar. So it's the watertight connection at the contact entrance. The body is more rust resistance material. So இங்கெல்லாம் நான் வந்து என் மோட்டாரை வந்து சப்மர்ஜ் அடியில வைக்கிறேன், அந்த வாட்டர் டைப் அந்த மாதிரி இடத்துல எல்லாம் I can use for the drip proof type because it can be rust resistance material. So உங்களுக்கு தண்ணி போகாம வச்சுக்கோ அந்த enclosure. So there you can use it for the drip proof type. And then next is totally enclosed type. The totally we can use it for the very dusty atmosphere. So the maximum it is used for the straw mills or coal handling plants. I can use it for the totally enclosed type, which means I can totally cover my drive or motor. Because but here's one drawback: there's a non-ventilation because there is no ventilation there in the totally enclosed type. So in that cases, I need a special arrangement to cool off my machines. So I can in some cases they have a fitted design for the fan and then cooling fan or another arrangement for cool my machine. I'm repeating once again. In some very very dusty atmosphere, I can use for the totally enclosed type enclosure. In totally enclosed type, there is one disadvantage: there is no ventilation. So for ventilation purpose, I can again design for some special fans inside my totally enclosed type. So the fan is used for the cooling purpose because whenever my motor is running, it will be heated up. So again, I need to cool off my machine. So in totally enclosed type, I need a special arrangement to ventilate my drive. And then the last one is flame proof type. Flame proof type means it can be used for the explosive atmosphere. Explosive atmosphere means I can use for the flame proof type. So it can be used for the very strong cover because in explosive atmosphere, if you are used for the less cover, which means thin cover means it may be get heated up or fired up. In order to avoid that, my enclosure will be a very strong cover. So it can be withstand any explosion of gas inside the motor and then without transmitting the flame. So there I can use for the flame proof type. Again, this type of flame proof I can use for the coal mines. So I'm repeating once again the selection of enclosure. The selection of enclosure, why I'm moving to the event, in order to prevent from dust or some environment aspects, I have to enclose my motor with some arrangement. So there I can divide it into screen type, drip proof, totally enclosed, and flame proof. Screen is nothing but the machine is covered with the wire screen, and then here the ventilation is possible, and then it doesn't protect from the dust. And then because if it is screen type, there is loss of dust may enter into the screen type. And then another advantage of the screen proof type is coming in contact with the motor. For example, rats and squirrels and also human beings, it is prevent from the coming contact with the motor. And the next one is drip proof type. This type is used for the atmosphere is damp or submerged. In submerged type, we can use the drip proof enclosure type. The motor has very tight connection with this type of drip proof is very rust resistant material we can use for, because there is no it will be avoid the water will enter into the motor and all. So that's why the drip proof type material we have choose the rust resistant material. And then totally enclosed type, This type of totally enclosed type we can use for the very dusty atmosphere because very dusty atmosphere means there is a possible of dust may enter into the motor. There I can use for the totally enclosed type. It is totally enclosed means there is no ventilation purpose. So in order to cool off my machine, some special arrangements are we have to set for providing fan. It will be used for cooling the purpose. So for totally enclosed type, we need a special arrangement to cool off my motor. And the last one is flame proof type. Flame proof type is nothing but it can be used for the explosive atmosphere. So it must be a special type of strong covers because it can be able to withstand any explosion of gas inside the motor and then without transmitting the flame outside the motor. So that's why it can be used for the explosive atmosphere. And then mostly the flame proof type of motor can be used for the coal mines. So this is the selection of enclosure. If you have any doubt, please ask now itself. If you have any doubt, please ask now itself. Any doubt? Any doubt? I'm asking with you only. Do you have any doubt in selection of enclosure? Somebody unmute and say, have you all understood or not? Have you all understood?
Yes, ma'am.
ಯಾರಿಗೆ ಎಂದ doubt
Yes, ma'am.
ಇದೆಯಾ? There is no doubt in it. And then randomly I call a name and then I make a question. 19M109 Murugesan. Murugesan. 19M109.
Yes, ma'am.
What is mean by screen protected type enclosure? What is screen protected type enclosure? M228. Sujikant. What is his name? 19M228.
மேம் ஸ்க்ரீன் ப்ரொடெக்டட் வந்து டஸ்ட்டுக்கு மட்டும் மேம் ட்ரிப்பு வந்து இந்த வாட்டர் மேம் ஸ்க்ரீன் ப்ரொடெக்டட் வந்து இந்த டஸ்ட்
What is screen protected type?
மேம் டஸ்ட் டர்ட்லாம் போய் கிளாட் ஆகாமல் இருக்கிறதுக்கு ப்ரொடெக்ட் பண்ணுறது ஸ்க்ரீன் ப்ரொடெக்டட் மேம்
அவ்வளவுதானா?
டஸ்ட் அண்ட் டர்ட்
What is another point?
வேற என்ன மேம் ஓரளவு லார்ஜ் பார்ட்டிகல்ஸ் உள்ள போய் மாட்டிக்காம இருக்கிறதுக்கு மேம்
Okay, good. Next 19M228. Unmute your mic. 19M228.
Yes, ma'am.
What is synchronous motor? What is synchronous motor?
It has run at 1500 RPM.
Okay. And then
It has constant
what
speed.
are the advantages of a synchronous motor? What is the advantage of synchronous motor?
Um, depends on the power factor.
Pardon?
Depends on the power factor.
I didn't get your point.
Depends on the power factor.
Can you repeat
It's
once again?
constant speed motor.
The stage is 1,500. It runs at 1,500 RPM. What is the another point? What is the another point?
Um, there's limitation, disadvantage.
இதான் என்னன்னு கேக்குறேன். What is the disadvantage of synchronous motor? Asking you only what is the disadvantage of synchronous motor? One 26 current, 19M 126. One 26 Sharon, Selva Kumar, 127.
Ma'am,
What are the disadvantages of synchronous motor?
புரியலங்க மேம். What are
What is the disadvantage of synchronous motor? What is the limitation of synchronous motor? Marking with you only. ஒண்ணுமே எழுதியோம் என்னோட நோட்ல. Yes. எதுவுமே எழுதியா நீயே? I have asked thee what are the disadvantage of synchronous motor. I have said twice what are the advantage and disadvantage of each motor.
எழுதிருக்கேன் மேம். கிளாஸ் முடிஞ்சு அனுப்பிடுறேன் மேம் உங்களுக்கு.
எழுதிருந்தீங்கன்னா என்ன டிஸ்அட்வான்டேஜ் சொல்ல வேண்டியது தானே. எழுதுறது முக்கியம் இல்ல, என்ன கவனிச்சுக்கிறது தானே முக்கியம். எழுதியிருக்க சரி, என்னன்னு சொன்னா தானே தெரியும்.
எஸ் மேம்.
212 Karthikeyan. 212 Karthikeyan. Others, you may attend the quiz. I have posted in the chat box. Please attend the quiz. If you are attend the quiz only, then I can give the attendance. The last class, around 63 only attended. Karthikeyan, are you there or not? 212. 19M 220 Praveen Chandru.
சொல்லுங்க மேம். எஸ் மேம்.
What are the disadvantages of synchronous motor?
என்ன மேம்? வாட் ஆர் த
Disadvantages of synchronous motor.
இன்டர்நெட் மோட்டாரா மேம்?
Synchronous motor. Others, have you all attending the quiz?
மேம் பர்மிஷன் கேட்குது மேம். மேம் கூகுள் ஃபார்மில் பர்மிஷன் கேட்குது மேம். மேம்
தம்பி லாகின் வித் யுவர் காலேஜ் மெயில் ஐடி.
ஓகே சார்.
காலேஜ் மெயில் ஐடி போனீங்கன்னா அப்படி கேட்காது, பர்மிஷன் கேட்காது. ஓகே
சார் லாஸ்ட் கிளாஸும் இப்படி தான் சார். என் காலேஜ் மெயில் ஐடி தான் சார் இது. ஆனால் இப்போ லாஸ்ட் கிளாஸில் உள்ளே போனது சார். இந்த கிளாஸ் போக முடியுது.
சரிப்பா, நான் ஒரு சரியா
யாருமே அட்டம் பண்ண முடியலாமா அந்த quiz-அ? யாராவது ஒரு வாட்டி அதை ஓபன் பண்ணி பாருங்க சார் போதுன்ட்டு. What about others? எல்லாருக்கும் எதுவும் ப்ராப்ளம் வருமா? ஓபன் பண்ண முடியலையா அதைய? All of you, are you able to open the quiz or not?
எஸ் மேம். ஓப்பன் ஆகுது மேம்.
மேம் ஓப்பன் ஆகுது மேம்.
யாருக்காவது டவுட் இருந்தா இப்ப கேட்டுக்கோ சார். ரெக்கார்டிங் க்ளோஸ் பண்ணிடுங்க சார். 11:45 12:45 ஆயிடுச்சுங்க.
ஓகே ஓகே.
எஸ், எனி டவுட்? யாருக்காவது டவுட் இருந்தா இப்ப கேட்டுக்கோ. All of you, was attend பண்ணதா attendance?